Okay, so in this video, we're going to go over Inequalities Introduction Part 2, and we're going to cover specifically these two topics. When do we switch the direction of the inequality? Because there are times when we're going to have to do that. And how do we graph two variable inequalities? Okay, so let's just deal with these one at a time. So let's start with this first one, switching the direction of the inequality. Now, remember that there are 5 different kinds of inequalities. There's greater than, there is less than, there's greater than or equal to, there's less than or equal to, and then there's also not equal to. In this particular case, we've got just the less than sign. Now, how do I know that it's less than? Again, you're always reading left to right, and whatever part of the inequality you come up first. So if it's the small closed part, you would say less than because it gets larger as it goes this way. And if you're coming like from this side, for example, you're coming this direction, you see it's open and it's getting smaller, so it's greater than and getting smaller. Okay, so that's how you read that. But let's take a look at this problem. Now remember in one of the introductory videos, the last one, I said that you treat this just like it were an equation. All right, so let's just use the same rules. Let's subtract 1 from both sides, and I'm going to get a 4. And this is where this switching of the direction comes in. Whenever I'm going to divide by a negative number or multiply by a negative number, you have to switch the direction of the inequality in your next step. All right, I would end up with x is greater than -2. Now, why is that? I think maybe if we graphed it on the number line, we would see what the problem is, okay? Or the answer to that question, actually. Now, I'm looking for all the x's that when I plug them in here, they will end up being less than 5. Okay, so let's just choose a random number. Let's just choose like 2, okay? If I chose 1, 2, and I plugged it in here, I would get 2 times, -2 rather, times 2, sorry, there we go, plus 1 is less than 5. Let's see if that's true. That times that gives me -4. That plus that gives me -3. Is that indeed -3 less than 5? The answer is yes, it would. So it looks like everything from -2 on up should work, okay? Or +2 rather. Now let me just go down this direction. However, this says everything greater than -2 should work. And remember, I'm supposed to follow the arrow here. So according to this, everything on this side of the open -2 should actually fulfill this problem. And it's a good thing that I went ahead and switched that direction, because if I hadn't, I would have x is less than -2 going in that direction, and any number down here would not have filled this problem in. Let me just check it to make sure. So for example, if I had chosen, like, let's say -3, -2 times -3 plus 1 less than 5, that would give me +6 plus 1 less than 5. That would be 7 is less than 5, and that's clearly not correct. So it was a good thing I went ahead and switched that. So here's the rule. Always switch the direction of the inequality when multiplying or dividing by a negative number. And to prove it to yourself, just go ahead and choose the number line, the number on that number line, and see if it actually fulfills the answer, okay? Now, the second thing I want to do in this short video is to show you how to graph 2 variable inequalities, all right? So let's just go ahead and do that. Now, let's go ahead, and 2 variables means that I need an x-axis and a y-axis. There's my y, here's my x. Okay, and let's just take a very simple two-variable inequality. Let's say I have the inequality y is greater than 2x plus 1. Now, remember that this is really the same form as the slope-intercept form of an equation. Remember that? Where this is the slope and this is the y-intercept, also as y is mx plus b. Same idea, right? Now remember, to do this, I would do the exact same thing I did with an equality. I will just ignore this, pretend it's equal, and then just go ahead and graph. This tells me that my y-intercept is at positive 1 along the y-axis. And this tells me that my slope is rise 2, run 1. So up 2 over 1, up 2 over 1. Okay, so that would be 1, that would be 2. Now this tells me that this is where my line would be. Okay? Except that here are the rules that you need to follow. If there is no equal sign here, then you need to keep this as just a series of dots, because this is kind of marking the boundary of the points that will work in this inequality. Now, let me show you which side I'm going to shade. Okay? Now, to figure that out, I normally do what's called a test point. Now, let me talk about what that means. I've basically just divided my graph into two halves, haven't I? Everything that's on this side and everything that's on this side. If I were to choose a point on one side or the other, let me just choose 0, 0, because it's always easy to use. And if I were to put it into here, all right, so I'm going to choose, the test point is 0, 0, and I insert 0 into my y, 0 into my x, and see if this is a true statement or not. According to this, 0 would be greater than 2 times 0 is 0, plus 1, or 0 is greater than 1. Is that true? And it's not, is it? That tells me every point on this side of this line will not work. Therefore, I will shade in the opposite direction. Okay? And I could go ahead and I'm sorry about that. Go ahead and just kind of shade on this side. Okay? Now, here's what's interesting. I don't have a solid line here, though, because if I were to choose like one of the points on this actual line, like for example 0, 1, according to my y-intercept, let's see if that would actually work in this inequality. So my y is 1, my x is 0, and let's see if this statement's true. 1 is greater than 0 plus 1. Is 1 greater than 1? Again, the answer is no, but that happens to be a point that's right on the edge of this line. So instead of making it solid, which would include that, or when there'd be like an equal sign here, that would make this solid, I leave it dotted and broken only. So everything not on the line itself, but just to the left side of the line works. Okay, I hope that was helpful. Quite a long video, but it covers two main points. And that again is, when do I switch the direction of the inequality? Again, when you're multiplying or dividing by a negative number. And then how do I graph two variable inequalities? And I went through the steps for you right over here. Okay, hope that was helpful.